Ever wondered how to calculate the cross product of two vectors? The cross product, also known as the vector product, is a binary operation that combines two vectors in a three-dimensional space. The result? A vector that stands at a right angle to the initial two vectors. The cross product of two vectors, let's say a and b, is depicted as a xb, and it's not as complicated as it might seem at first glance. The formula for calculating the cross product is, here a and b are the magnitudes of vectors a and b, theta represents the angle nestled between a and b, and n is a unit vector that stands perpendicular to both a and b with a direction that makes the ordered set, abn, positively oriented. The cross product reveals some fascinating properties. This concept and its calculations have a wide range of applications, including calculating the force on a current-carrying wire in a magnetic field, measuring the torque on a rotating object, determining the angular velocity of a rigid body, and even calculating the velocity of a fluid particle in a rotating frame of reference. Scene script. Imagine you have two vectors at equal sign, 1, 2, 3, and b equal sign, 4, 5, 6. Here's how you would calculate the cross product. First, calculate the magnitude of each vector. Next, calculate the angle between the two vectors. Then find the unit vector that is perpendicular to both a and b. Finally, you can calculate the cross product. Applying these steps, you end up with a cross product of output. To wrap up, the cross product is a binary operation on two vectors in three-dimensional space. It's a non-commutative and non-associative operation that results in a vector perpendicular to the initial vectors. The calculation involves finding the magnitudes of the vectors, the angle between them, and a unit vector perpendicular to both. With these elements, you can calculate the cross product and apply it in various fields, including physics and engineering. So the next time you encounter a cross product, you'll know exactly what to do.